Hello everybody. This is a chapter, or this is the lecture that we will discuss bringing in multimedia to into our web or into our web pages. Before we use the HTML5, we used to use another form of multimedia, which was Flash. And Flash was created during the PC era for PC, and it was a very successful model for the company Adobe, and it went on for quite some time. However, with the mobile era coming about, we realized that we now have lower power devices, we have touch interfaces, we have open standards, and in all of these areas, Flash fell a little short. So right now, Flash is no longer a big player to watch video or consume any kind of web content. Now, there are still some websites which uses Flash, but we are seeing more and more new technologies adopt HTML5 in displaying multimedia on their web pages. So like many other new technologies we have looked in, the open source HTML5, in the open source HTML5 standard, the new audio and video elements are much more mature than ever before. It's a good thing because user expectations for multimedia are much higher nowadays than ever before. We used to do business over slower internet connection, but now the bandwidth pipe has gotten much fatter, and our demand for interactive entertainment has become virtually insatiable. It's time for the money shot, and you are looking for some new technologies which would be able to deliver all of that, and HTML5 have done a great job in doing that. For years, the battle was between QuickTime and Real Player and Flash for video playback, but these browser plugins were easy to install and usually produce the expected results. Over time, the QuickTime and the Real Player continued as playback platforms, but the makers of the proprietary Flash tool also created a robust development environment, allowing not just designers but also developers to see it as a viable platform. So before we get too much into the different kinds of file format, let me bring up something that is really important when we try to understand latency and bandwidth. As you can see on your screen, if we think of the internet as a series of tubes, what we define as latency is going to be the length of the tube between 2 points. When we are talking about experiencing audio or experiencing video on our web, we are actually contacting a server and downloading some of those files. So the distance is important. So the latency would be the distance between the two tubes, or between 2 point in that tube. However, the bandwidth is how wide the tube is. Okay, so when we talk about bandwidth, it describes the width of communication. It is an important factor in the application of multimedia because it designates the measure of the amount of data that can be sent through the communication pipeline each second. Now, the travel time, okay, as explained in the picture, is the latency, where bandwidth is the width of the tube. If I scroll down, this is a great picture I found again on the internet, which describes why a wider bandwidth or the width of a bandwidth matters. Uh, the width of a bandwidth matters because that way you can send the files simultaneously. So here we see two connections. One is with low bandwidth, the one on the top, and the one is at high bandwidth. So when we are transmitting a JPEG file for our purposes, the connection across both of the connections, the latency for the first byte of data to travel from the source to the destination is the same. So as you can see, the latency is still the same. However, the high bandwidth connection enables the downloads to be a little faster than the low bandwidth because more data can travel in parallel. Okay, so that's an important concept. So even though the distance is the same between the 2 points, having a wider connection allows the data to travel in parallel, which gives you a much shorter of a download time. So this picture, I really feel that explains why it is important and why bandwidth is important. Okay, so make sure you understand the difference between the latency and bandwidth. Let's talk a little bit about the internet connections that have evolved over time. When we use audio or video files, or in other words, multimedia, we have to be careful about the internet speed because it does take, just like I showed you earlier, it does take the file to be downloaded from the server. With the new development or availability and affordability of high-speed connection to the general public, having DSL, cable modes, we have found that we had increased the internet access and more people have access to those faster connection. The second development that had happened is also very important, which was the reduction in the file size. So the reduction of the file size in media clips without sacrificing the sound or the video quality through the use of file compression technology is very important in bringing more or adding more audio, video, or multimedia to our web page. So paired together, the two developments made multimedia much more accessible to the internet users, eventually resulting in the creation of one of the most popular website on the internet nowadays, which is the YouTube. There are a lot of different sites similar to YouTube, but that's a great example of how easy it has become to publish or have multimedia on the web. Now, YouTube by itself allows you to create and upload those files, but the concept is very similar to what we would be doing with our pages. We are creating our web pages where we would be uploading or we would be including those files. Those are either an audio or a video files, which could be viewed by or viewed and played by the users. Let's talk about a few other terms that are important. Let's talk a little bit about plugins. When we talk about multimedia, multimedia is displayed within the web page in a fashion very similar to an image that you include on your web page. The controls to play those media clips are also displayed as part of your web page. To play those multimedia files, a browser often had to have access to a plugin or an add-on. And plugin or an add-on is an extra component accessed by the browser to provide a feature or capability which is not included or which was not included previously with the browser. The most commonly used plugins for multimedia for the Windows format was the Windows Media Player. The QuickTime, it was another plugin for video and audio clips, and Adobe Flash Video for the video, audio, and animation. However, as we talked about very early in the introduction, starting with the widespread adoption of HTML5 elements, and as it matured, it really did allow for all of these things to be included within the browsers nowadays, because more and more people are including those audio and video files, and the browsers, which basically is a way of interpreting some of those HTML codes, are including those plugins by default. So starting with the widespread adoption of HTML5, many browsers now do include a built-in support for audio and video files, removing the need for an additional download for those plugins or add-ons. Let's see some of the, or let's talk a little bit about a few other terms that you're going to come across when you're dealing with multimedia. On your screen, you are actually looking at very simple sound wave, and there are a couple things I would like to mention. One is the amplitude. The amplitude is the height of the sound wave, and it relates to the sound volume. So as you can see over here, this line over here is the amplitude or the height. So basically, if I draw a line from here, all the way down to this line right here, that is going to be my amplitude, okay? And that would determine my volume. So the higher the amplitude, the louder the volume is. Whereas the other term that you would be looking at would be frequency. So a frequency is the speed at which the wave would move. So it would relate to the sound's pitch. So one is the amplitude, which is the height, and the frequency would be the speed of how the sound wave would move, and that would relate to the pitch of the sound. So higher the frequency, the higher the pitch. Also, when you hear sound, you're hearing continuously a varying signal created by the vibration in your eardrum. And to store that sound in a computer file, you have to convert it into some discrete pieces of information, and that is going to be referred to as bits. So these discrete pieces of information that you are recording, which is stored as a computer file, would be the bits. When we talk about digital recording, we are talking about the digital recording of that sound that makes measurement of the sound wave at different moments in time. each measurement would be called a sample. So when you talk or when you hear about the sample rate or the sampling rate, this is what it's talking about, that the sampling rate. So we talked about the sample, which is basically um, the digital recording of the sound wave at different moments of time, and the sampling rate would be the number of samples taken per second would be the sampling rate. And you might see some pictures where they'll say, if I take a sample at this point, so let's say I draw a line at over here, and I take another sampling at this point, so then there's a space between these two, and that would be a lower sampling rate. However, if you take a sample at this point and right next to it and right next to it, that way you will have a much higher sampling rate. So that's basically some of the terms that you would keep on hearing about when we talk about digital audio. Another factor, before I move on, you would probably hear another unit, which is the sampling rate unit, and that is measured in kilohertz. So if you're talking about the value, which is, as you can see, the kilohertz, it's that one cycle, and as the picture shows, it combines when it reaches the top and also it reaches the bottom. So that's why when you see that one cycle going top and the bottom, that's your entire cycle that you're referring to. Another factor that you would see, which comes into account when you are converting sound into a digital form, is the sample resolution. Okay, the sample resolution, or the bit depth, indicates the precision in measuring the sound within each sample. Okay, for our purposes, you really would not have to worry too much about these things, but I want you to be aware of the terms, because you are going to be hearing those things pretty common. You might also hear something called a sample resolution value, and basically there are three ways you can do this, or three commonly used sample resolution values are 8-bit, 16-bit, and 32-bit. Okay, but remember, your bits are those discrete pieces of information that you are converting when you are storing these sound waves into computer files. Okay, with increasing sample resolution creates a digital sound file that represents the signal that you are seeing more accurately. In layman's term, what it means is, the higher those sample resolutions are, the better quality sound you produce. So when we say that it is resembling more closely to the analog signal, you're talking about the quality of sound. Okay, and again, sometimes you will hear some of the discussions when they're talking about optimal performance and the quality of sound, especially if you are trying to create a website where you are demonstrating, if it is a website that you're creating for a company which, let's say sells acoustic devices, then, those things become much, much more important. Another thing I want you all to know is that when you are storing those sound files, the size of an audio clip, therefore, would be related to the sampling rate as to how many times it has been collected, and the sample resolution, and the number of channels that you are using. Okay, the total size can be expressed as bit rates, which is the number of bits of data that are required for each second of sound. Okay, we also know the term, or we would also hear file compression, which basically is compressing bigger files into smaller files. The most common file compression format is the MP3 format, and this is very, very widely used throughout the web as well as on portable music players. An MP3 player can achieve near CD quality sound at bit rates of 192 to 320 kilobytes or kilobits per second. Okay, why is the file compression important? It is because when we deal with the quality of sound, the more loss we suffer in the compression, the quality of the sound goes down, or the quality would deteriorate. However, the newer formats that we would be using for most of our purposes has very little loss in the sound, which basically translates to better quality sound and better transmission. Remember, when you're downloading those files, it would take much less time when you have compressed files. The audio format supported by HTML5 is either one of these three things, which is either an MP3 or OGG Vorbis or a WAV. You're going to be seeing those files quite frequently. The MP3 is the most popular for downloading and storing music. It does compress the sound files to roughly 1/10 of the size of an uncompressed file while maintaining good audio quality. However, sometimes MP3 is proprietary and it is not royalty free. The other kind of compression is other kind of the format that you'd come across is the OGG Vorbis. It's also a file compression format which is designed for web audio. It is an open source and royalty free, and it does provide better quality sound than MP3, especially at lower bit rates. However, it is not always as widely accepted as MP3. The other kind is the original audio format for the Windows version of the PCs. That is the WAV. So WAV is commonly used for storing uncompressed. Remember, it is an uncompressed CD quality sound. Of course, when you say uncompressed, the sizes are much bigger. So there is a difference between using MP3s and WAVs. In this format, in the web or the WAV format, the file requires about 10 megabytes per minute of sound, so it is a much larger file. Let's move on to, before I move on, let me also mention another thing here, that whenever you use any of the multimedia, and we are only referring to audio files at this point, it is always a good idea to check for compatibility and for functionality. We will look into the element codes later on in a lecture, but right now, when you include those files, always make sure that you try it out in multiple browsers just to see if everything is working fine. When we insert an audio into our website, the element would also give us audio controls that we can include, which would show the kind of player that you are incorporating on the website. The appearance of the audio control varies from browser to browser. So if you want your audio control to share, or audio, even with the video control, if you want your audio and video controls to share a uniform look, then you must create your own by using, maybe JavaScript program which would manage the action of the individual control buttons. But remember, if you but creating those things would require a little more programming. HTML5 does include some parameters that would make things a little easier, and you may not have to you may not have to create your own controls, but always check for compatibility across different browsers. Some of the older browsers which do not support HTML5 audio element, okay, we will have to use plugins, okay. Um, and the way we do it is we say that we would insert an embedded object within that website. Again, the way we would include that embedded object is with a particular element, and we'll say embed, that's the element that we would use with the source file, and that would allow for browsers which does not support HTML5 to include audio files. When we talk about embedded objects, I want to clarify that embedded objects are not only limited to audio and video files only. They can also be used for other objects such as images, interactive programs, and even other web pages. A multi-purpose internet mail extension, or MIME type, would identify the type of data contained in a file and provides the information about how the data should be interpreted. What I mean by that is, remember that your HTML, or the language that you use, is being interpreted by the browser. So the browser actually knows how to read the code. So by using those MIME type, you are identifying the type of data that is contained within that file, and would provide that information to the browser as to how to interpret it. So if it's an audio file, it knows that you have to play it. Now you have to include some audio player control with it. If it's a video file, it knows how to do it. If it's an animated picture file, then it knows how to do it. So those are basically in general termed as the MIME types. And there could be different kinds of MIME types. So you could have different kinds of audio MIME types, like AU format, MP3 format, MIDI format, real audio, shockwave flash, the WAV, and each of these things would have its own extension. So an AU format would be an audio basic, where .au. MP3 would have the file name with a .mp3. It's an audio MPEG file, and of course your ogg would have a .ogg, and so on and so forth. If you're talking about a flash file, a shockwave flash file, it will have a .swf extension. For a WAV file, it's going to be a .wav file. So those are the different kinds of MIME types, or different kinds of audio format that you would come across. Last but not the least, let's talk a little bit about video files, video bit rates and video quality. A video is composed of a series of single images or frames, okay, which are played in rapid succession to create an illusion of motion. I'm sure most of you guys have seen the animation, or how you started your animation by starting to create those individual images and then kind of flipping through it, which kind of makes you look, or makes that illusion that that figure is moving. So initially what happened was, people, or these cartoonists, used to draw those single images. So if you're trying to show that a certain character is moving your hand, you would create an image with the hand movement showing one, and then the hand movement showing a little more. And if you're flipping through it, it just shows, or it feels like the the character is moving their body parts. With the computer coming in, those things could be done much simpler. And of course the quality, the speed that you move kind of gives that smooth transition or smooth animation. So let's talk a little bit about that. So we already talked about the frames, and many frames are sized to have a width to height ratio and what is called the aspect ratio. Generally, you would see a 4:3 aspect ratio in most of the theater releases. So you sometimes when you're trying to publish a video file, it will ask you for that aspect ratio, and that is basically what it means. The two most common frame sizes for the web are either 160 by 120 pixels, or maybe 320 by 240. Frame sizes as large as 640 by 480 are becoming more and more common as the connection speeds are increasing. Sometimes some of the movie sites like Netflix or Hulu or Amazon would allow you to have instant video with high definition movies at resolution of 120 1280 by 720. By the way, when I create these videos, I generally use the 1280 by 720 to give a better resolution. So basically the speed at which one frame for a video is replaced by the next is called the frame rate. So that's why I mentioned earlier the speed is important as you go from one frame to the other. And that is commonly expressed as frame per second. So that's the FPS. The higher frames rates usually, but not always, result in a smoother animation that you see. DVDs generally have a 24 frame per second refresh rate, but commonly used on the web. Those are anywhere between 10 to 15 frames per second would give you a good quality video. As I mentioned earlier, the frame rate is not the only factor. Another factor is the video bit rate, which is the amount of data that has to be processed by the video player each second. So not only that speed of those frames is important, but the bit rate is also very important, which is the amount of data that needs to be processed by the video player. Again, I'm not going to get into too much details. The video bit rates are defined in megabits per seconds. So you will hear things like Mbps or kilobits per second, which is kbps. The DVD quality video has bit rates of anywhere between 4 to 8 Mbps, megabits per second. You've already heard things like Blu-ray video, which is about 25 Mbps, which is 25 megabits per second. And of course, the higher megabits that you see, the better quality or more clarity you would find in your video. Most of the video on the web would probably have about 800 kbps. So as you can see, that is much less, or much lower, slightly less than 1 Mbps. So there would be a difference when you're playing things from the web versus a DVD or a Blu-ray. However, movie websites typically would have anywhere between 2 to 3 Mbps, which is a little better quality, and it gives you better picture. Now, it is probably a mistake if you think that higher bitrate would always result in better video quality. You must also take into account the bandwidth, the connection to your website. So that's something that we mentioned about the latency and the bandwidth very, very early on the lecture. So the bandwidth must be large enough to accommodate the amount of information processed each bit or each second to smoothly play the video. So if a user tries to play a video with too high of a bitrate over a slower connection, then the playback would be choppy. So it's important to know the right balance of the connection speed, the bandwidth, and the the Mbps, that rate that you are trying to process things. So with that, I think we have covered. One more thing that I want to mention is some of the video formats that you're going to come across are things like Flash video, MP4, Awk Theora, WebM, and they would have the proper extensions like FLV for the Flash video, MP4. That would be the one that is most widely used. The Flash video is proprietary. The widely used, another widely used proprietary one is MP4. Apple uses a lot of MP4. You have the OGV, which is the Awk Theora. This is an open source format. So these are some of the file formats. And just like I had mentioned during my audio, for the audio part, if you include your video, you also need to make sure and check the compatibility of the video files. I think with that, we pretty much have covered some of the basic concepts. Once we get into the lecture showing the code, you will get more into the audio element of HTML5, the video element of HTML5. We'll also look into the object that we can bring in, and how we are bringing those things in. With that, I'll end this lecture and continue with the real code on my next lecture. Thank you.